So we are now going to find the volume of the second prism, which is this one. Now you'll notice right away this one looks different from the hexagonal prism that we just did. One reason, of course, is that it's not hexagonal. I don't see a hexagon. What I see are 3 rectangles and 2 triangles. The other thing is that this prism doesn't look like a prism at all because it's been flattened out. And in fact, when it's flattened out, we have a name for that, and it's called a net. And so what I want to show you is that any 3-dimensional figure can be flattened out to its net. So if you take this box right here that I've got, and I just unfold this box and flatten it out into its surfaces, this is now what we would call the net of this box because we flattened it out so that we can just see its surfaces. And this is some snail cream that I got in Thailand. I haven't tried it yet. But this is the net. So what we're looking at here is the net. And so as we're analyzing this, we just have to figure out what would this figure look like if it were folded back up to be 3-dimensional so that we know what we need in terms of base and height and how to plug into the formula. So speaking of formula, let's get to it. So the volume is still capital B base times height, just like before. And you'll remember that capital B base stands for the area of the base of the prism. In this case, the base is a triangle. So I'm imagining if I folded this net back up, what I would have would be 2 parallel triangles connected by 3 rectangular faces. So the only thing that really comes to mind is a Toblerone bar. That's a triangular prism that you may have seen before. So that's something that you might just think about. So when we want the area of the base, we have to think about what's the area of a triangle. I know you all know it, so let me hear you say it. What's the area of a triangle? You're right, 1/2 base times height. So we're going to plug that in. Now here's where things are going to get a little bit interesting. So let me plug it in. And I'm going to make some distinctions because what you're now going to see is that we have a couple of different heights that we are talking about. So we'll need to make a distinction between the height of the triangle and the height of the prism. So when I plug in the area of my base, that's going to be, that's right, 1/2 base times height. I'm going to distinguish, it's the base of the triangle times the height of the triangle. So you see I put that little subscript there to distinguish. I'm talking about the height of my triangle and the base of my triangle. And then for volume, I still need to multiply that by the height of my prism. That's a different height. So I'm going to distinguish that height, and I'm going to do a little subscript here, prism. So I'm going to be multiplying 1/2 base of my triangle times the height of my triangle times a separate different height, which is the height of my prism. So now let's take a look at our figure and see what we've got and what we can plug in. And in fact, what's interesting about this figure is we have more information here than we actually need. So we're going to have to pick out what's important and what we need to find the volume of this prism. So I'm going to start by looking at the triangle. So when I look at this triangle here up top, I see that an altitude has been drawn in. I know that because of the, that's right angle right here. So the height of my triangle is 2. Now let's think about what the base would be. So I see the base of my triangle is right here. There's no measurement there, but if I look at this rectangle that's part of this lateral surface, down here on the other side of this rectangle, I have a length of 21. Now, I know in rectangles, opposite sides are congruent. So if this is 21, so is this. And that means the base of my triangle is 21. So I'm going to go ahead and put that into my formula. So volume is 1/2 base of my triangle, which we said was 21, times height of my triangle, which we said was 2. Now the last thing we need to figure out is what is the height of the prism. So if I look at my different measurements, what I really am looking for is the height of my prism is actually going to look to you maybe more like a length because it's going up and down because this is flattened out into a net. But it's still right here. So the height is going to be 30 of my prism. And you can think about the height as the distance between the 2 parallel faces. In this case, the distance between the 2 triangular faces. units. And so the height of my prism is this number right here, it's 30. So I'm going to plug that in. Now I've got everything in that I need. I'm just going to crunch the numbers. Right away I can see that the 1/2 and the 2 will cancel because that's going to make 1. So I can just multiply 21 times 30. Feel free to grab your calculator. I can do this in my head though. 21 times 30 I know is 630. So the volume of this figure, and I'm not given units, so it's 630 units, whatever they may be, and because it's volume, it's going to be cubed. And that's it.